Hi, Mrs. Pone here, and today we're going to look at coordinate covalent bonds. And a coordinate covalent bond is when one atom is going to contribute both electrons in a bond. And we're going to see an example of that to make it perfectly clear. Let's draw the Lewis structure for ammonia. Ammonia is NH3. Nitrogen has 5 valence electrons. It's in column 5A. A hydrogen each has 1, so that's going to be plus another 3 VEs to equal 8 valence electrons in total. Hydrogen is never the central atom when we're drawing Lewis structures. Nitrogen is going to be the central atom. And we're going to simply connect 3 hydrogens to it. That's how we do this. We just draw single bonds and count electrons. We've used 2, 4, 6 electrons. We have 2 more, and we know nitrogen needs an octet. So we're going to put these 2 electrons right above nitrogen. And that's our Lewis structure for ammonia. And we're going to see what happens if we have a hydrogen cation around. And the idea is, recall that hydrogen is 1, 1 on the periodic table. That means hydrogen has 1 proton and 1 electron. In its most common form, there isn't a neutron. So if hydrogen loses its 1 electron, it will become positively charged. So essentially, this is a bare proton. And that makes it very reactive. So if you had an ammonia molecule and there was a hydrogen cation there, well, this hydrogen cation is essentially going to say, hey, to this lone pair, you know what? I'm going to attach to you. I'm going to jump on you because this is really, really, really reactive. A bare proton is extremely reactive. So it's going to jump onto this, but the idea is the ammonia molecule contributed, this nitrogen contributed both of these electrons. In this case, nitrogen, like see this case here, nitrogen contributed 1 electron, hydrogen contributed 1, and they shared the bond. And each of these cases that happened, but in this case up here, the nitrogen is supplying both electrons in the bond, and hydrogen is not supplying any. So that's a coordinate covalent bond, when one molecule supplies both. And of course, now this is a polyatomic ion. It has a plus charge, so in order to draw the correct Lewis structure for this, we would have to put brackets around it and indicate the charge. And nitrogen is contributing both valence both electrons in that bond. Same thing can happen with water. We have an H2O molecule down here in the bottom left. And we're going to see how water turns into hydronium, which is going to be extremely important when we talk about acids in our next chapter. So we have a water molecule, and there's 2 lone electron pairs, which actually cause water to be bent. And we have, again, a proton, a hydrogen cation. What it's going to do is it's going to say, hey, you know what? I'm going to attach to one of these lone pairs because this proton, this bare proton, is extremely reactive. Even though water itself is pretty stable, water's not like, hey, I want you. But this is so reactive, it's going to latch on to the water molecule. And when it does, we now have hydronium. Instead of H2O, we have H3O. But this is going to have a positive charge. Why is this going to have a positive charge? Well, essentially, you took a water molecule and you just add water molecules neutral, same number of protons and electrons, and you added a proton to it. You added a positive particle to this molecule, so the charge is going to be a +1. And of course, we would need to put in our brackets and our charge to finish this correctly. It is an ion, polyatomic ion, so we have to draw the Lewis structure like this. And that's how we draw that. And I believe we skipped one slide. I just want to do one thing. I want to compare the formal charge of these 2 molecules for you. One's a polyatomic ion, and again, this should be brackets, plus sign. Formal charge. Now remember, the formal charge of all of this should add up to this +1. And hydrogen, we know a single bond on hydrogen is always going to have a formal charge of 0. You can do the math out if you want, but these are all going to be 0. So hopefully nitrogen is going to have a formal charge of 0 here as well. We'll see what happens. Nitrogen has 5 valence electrons. Number of valence is 5 minus the number of unshared electrons. There's 2 unpaired electrons plus 1/2 of the shared, or the number of bonds. It's sharing 2, 4, 6 electrons and 3 bonds. So this could be just bond number here, 2 plus 3. So 5 minus a 2 plus 3, 5 minus 5 is 0. So the formal charge of ammonia equals 0. What's the formal charge on the nitrogen over here? Well, here we have number of valence electrons is going to be 5 minus How many unshared electrons are there? We don't have any unshared electrons. So 0 plus half of the shared, or the number of bonds. There's 1, 2, 3, 4 bonds. And we have 5 minus 4 is a plus 1. Formal charge of nitrogen is a plus 1. And all the hydrogens are 0, so that adds up perfectly. So these are coordinate covalent bonds. This is Mr. Spohn.